Hello everyone, welcome to the lecture again. In the last class, we look at the equation of motion in different coordinate systems and solve couple of examples for Cartesian coordinate. Today, we are going to look at examples in other coordinate systems. So, this is the first problem statement. A mass hangs from a massless string of length L condition have been set up so that the mass swings around in a horizontal circle with the string making a constant angle beta with the vertical. What is the angular frequency of this motion? So, let me make the free body diagram and look at the forces that are acting. So, we have this mass which is going in a horizontal circle, its mass is of course m, and the tension T is going to act along the string and it is making an angle beta from the vertical. Now, the relation between the radius of the horizontal circle that it is making and the length of the string L can be find out from the geometry. So, you can see that R is equal to L sin beta. Let us call it equation number 1. The force balancing along the y direction gives you T cos beta equal to mg, and the force along the r direction Fr is T sin beta. Now, let us look at equation of motion in the r direction. So, we have Fr equal to m r theta dot square, which can be written as m r omega square, and Fr I already know, it is T sin beta equal to m r is L sin beta into omega square. So, sin beta will get cancelled, you get omega equal to square root T over m into L. Now, this I can rewrite because from equation number 2 T is mg over cos beta. So, T is mg over cos beta into m into L, and m will get cancelled, we get omega equal to square root g over L cos beta. Now, note that for a simple pendulum we have beta equal to 0. Okay. So, let us see what happens when beta is equal to 0. If beta is equal to 0, then let us put there cos beta will be 1. So, we have the condition of simple pendulum. So, we get omega equal to square root g over L. This is something that we already know. Now, let us look at another problem statement based on flexible belt. The question statement is following: the flexible belt runs around two pulleys of different radii. At the instant shown, point C on the belt has a velocity of 5 meter per second and an acceleration of 50 meter per second square. In the direction indicated in the figure. Compute the magnitudes of the acceleration of point A and B on the belt at this instant. Now, in this question it is given that point C on the belt has a velocity of 5 meter per second and acceleration of 50 meter per second square. Therefore, the tangential component of the velocity and acceleration will be 5 and 50 throughout the belt. So, every point on the belt has same speed. Therefore, velocity at point A, velocity at point B and velocity at point C, its tangential component will be 5 meter per second. Similarly, the tangential acceleration, let us say acceleration at point A, its tangential component, and acceleration at point B, its tangential component, or the acceleration at point C, it will be 50 meter per second. So, this is again AT and BT. Now, let us analyze point A. At point A, the normal acceleration will be velocity square divided by its radius. So, that will be 5 square divided by 0.15, that gives you 166.67 meter per second square. Therefore, total acceleration A will be A normal component square plus A tangential component square. That means it is 166.67 square plus 50 square, that gives you 174 meter per second square. Now, let us look at point B. At point B, we have the normal component equal to VB square over R2. So, that will be 5 square over 0.1, that will give you 250 meter per second square. Therefore, total acceleration of point P will be square root AB square normal component plus AB square tangential component, that will be square root 250 square plus 50 square equal to 255 meter per second square. Now, let us look at another problem statement, and it is following. The 100 gram block B slides along the rotating bar OA. The coefficient of kinetic friction between B and OA is mu k equal to 0.2. In the position shown, r dot is 1 meter per second, theta dot is 5 radian per second, and theta double dot is 3 radian per second square. For this position, determine r double dot, the acceleration of B relative to bar OA. For r equal to 0.4 meter, the value of r dot, theta dot and theta double dot is given, and we have to find out the value of r double dot. Let us look at the free body diagram of the block B. So, along the rod, let us take r cap, and theta cap therefore will be perpendicular to it. The weight of the block, which is 100 gram, which is equal to 0.98 Newton, is going to act downward, and the direction of the friction will be opposite to the motion. So, let us take it in this direction, and it will be mu times n. Mu is given and n is the normal reaction, which will of course act along the theta cap direction. So, let us write down the equation of motion along the r cap direction and theta cap direction. So, we have f theta equal to m r theta double dot plus 2 r dot theta dot, and we have summation f r equal to m r double dot minus r theta dot square. From the free body diagram, let us find out what are the forces in the f theta direction and what are the forces in the f r direction. Now, you can see that the f theta or the force along the theta cap direction is n minus the component of the weight along the theta cap direction, which is 0.98 cos, and we have to determine all this at theta equal to 40 degree. So, this angle is 40 degree, therefore, cos 40 degree, and F r, the force along the r direction, is the frictional force, which is 0.2 into n, and n is something that we do not know right now. So, let us write it as n minus 0.98 sin 40 degree. So, let us use this equation. So, we have f theta, which is n minus 0.98 cos 40 degree, equal to m is 100 gram. So, therefore, 0.1, r is 0.4, and theta double dot is given, it is 3 radian per second. So, therefore, multiplied by 3 plus 2 into 1 into 5. So, this gives you n equal to 1.87 Newton, and now let us use the second equation. So, we have F r, which is 0.2 n. So, 0.2 into n, n is something that we know now. So, it is 1.87 minus 0.98 sin 40 degree equal to m is 0.1, r double dot is something that we have to find out, minus r is 0.4 into theta dot square. So, theta dot is 5, and this gives you r double dot equal to minus 0.04 meter per second square. And the negative sign here indicate that the acceleration of B, is directed towards point O. Okay. Now, let us look at another problem statement, question number 4. A platform has a constant angular velocity omega equal to 5 radian per second, a mass B of 2 kg slides in a frictionless tube attached to the platform. The mass is connected via a light inextensible cable to a linear spring of spring constant K equal to 20 Newton per meter. The spring is unstretched when the mass B is at the center C of the platform. Now, it is given that if the mass B is released at r equal to 200 mm from a stationary position relative to the platform, what is its speed relative to the platform when it has moved to r equal to 400 mm. And we have been also asked what is the transverse force on the body B at this position. In this question, we have been asked to find out the speed and the transverse force. To find out the speed, let us look at the equation of motion along the r direction. So, we have summation f r equal to m r double dot minus r theta dot square. Now, the force along the r direction is because of the spring, and the spring force F equal to minus kx, where x is the extension, which in this case is r, and k is given. Therefore, F r will be minus 20 r, m is also given, r double dot minus theta dot is also given. Theta dot is equal to omega equal to 5, therefore 5 square r, and from here we can get r double dot. So, r double dot is 15 r. Now, this r double dot is acceleration. So, it is dvr by dt, rate of change of velocity, and this again I can write down as dv by dr dr by dt, which I can rewrite as v dv by dr. Therefore, from this equation we have V dV by dr and everything is about the radial component equal to 15r from equation number 1. Now, I can integrate it to find out what is Vr. So, Vr dVr equal to 15r dr, let us integrate it. So, we have Vr square divided by 2 equal to 15 r square divided by 2 plus constant. Now, this constant I can find out from the initial condition that were set up in the problem. So, the initial conditions is at r equal to 0.2 meter, Vr is equal to 0. Okay. So, therefore, 0 equal to 15 into 0.2 into 0.2 divided by 2 plus C1 or C1 equal to minus 0.3. I can put this in equation number 2. So, we have Vr square divided by 2 equal to 15 r square divided by 2 minus 0.3. This I can rewrite as Vr square equal to 15 r square minus 0.6 and let us put r equal to 0.4 meter. So, we get Vr equal to 1.342 meter per second because we have been asked to find out the velocity at r equal to 0.4 meter. Now, let us look at the force. For the transverse force, because we have been asked to find out the transverse force, we know that F theta is equal to m r theta double dot plus 2 r dot theta dot. Now, all the values are given, m is 2, r is 0.4, theta double dot because it is rotating with a constant velocity, therefore, theta double dot will be 0 plus 2 into r dot is 1.342, that is the velocity along the r direction which we have just find out, multiplied by theta dot. So, theta dot is given 5 and this gives you 26.84 Newton. Now, let us look at another problem statement. The rod OA is held at the constant angle beta equal to 30 degree while it rotates about the vertical with a constant angular rate phi dot equal to 120 revolution per minute. Simultaneously, the sliding ball P oscillates along the rod with its distance in mm from the fixed pivot O given by r equal to 200 plus 50 sin 2 pi nt, where the frequency of oscillation along the rod is constant and it is equal to 2 cycle per second. And we have been asked to calculate the magnitude of the acceleration. Of p for an instant when its velocity along the rod from O towards A is maximum. In this question, the rod OA is rotating with a constant angular velocity about point O and the ball P is making an oscillatory motion. We have to determine the acceleration of P. So, first of all, we have to identify the right coordinate system, and for this problem the right coordinate system is the spherical polar coordinate. Therefore, we can find out the acceleration if we know what is AR, what is A theta and what is A phi. So, let us see the situation. In the question we have been given that R is equal to 200 plus 50 sin 2 pi nt and n is equal to 2. Therefore, R becomes 200 plus 50 sin 4 pi t, and therefore, R dot becomes 200 pi cos 4 pi t and R double dot is minus 800 pi square sin 4 pi t. Now, we have to find out the acceleration of point P for an instant when the velocity is maxima. So, velocity maxima means R dot has to be maxima and it can be maxima if cos 4 pi nt is equal to 1. Therefore, R dot will be 200 pi, and if cos 4 pi t equal to 1, then sin 4 pi t will be 0. Therefore, R double dot will be 0 and R will be 200. Now, in the question we have been given beta equal to 30 degree. Now, beta is the angle that it makes from the z axis, and this angle in our formalism we have taken it as theta. So, therefore, theta dot and theta double dot will be 0 because theta is constant. In the question we have also given phi dot equal to 120 revolution per minute. So, phi dot is equal to 120 revolution per minute. So, let us convert it into radian per second. So, 2 pi divided by 60, which is 4 pi radian per second. Again it is constant, therefore, phi double dot will be 0. Now, we are in a situation to find out what is AR, what is A theta and what is A phi. So, AR will be R double dot minus R theta dot square minus R sin square theta phi dot square. Now, let us put these values. So, R double dot is 0 minus R is 200 into theta dot square. So, theta dot is 0 minus R is 200 sin square, theta is 30 degree and phi dot is 4 pi. So, 4 pi square, and this you can find out, this is equal to minus 800 pi square meter per second square. Now, let us look at A theta. A theta is R theta double dot plus 2 R dot theta dot minus R sin theta cos theta phi dot square, and again R is 200, but theta double dot is 0 and theta dot is also 0 minus R is 200 sin 30 degree cos 30 degree into phi dot square. Phi dot is 4 pi square, and this you can find out, it is equal to minus 800 square root 3 pi square again meter per second square. Now let us look at A phi. A phi is 2 r dot phi dot sin theta plus 2 r theta dot phi dot cos theta plus r sin theta phi double dot. So now let us put the values. This is equal to 2 into r dot is 200 pi, phi dot is 4 pi and sin 30 degree plus 2r theta dot is 0 plus r sin theta phi double dot is also 0. So therefore this comes out to be 800 pi square meter per second square. Now total A will be square root A r square plus A theta square plus A phi square, which is equal to square root of this square plus that square, and this is equal to 17660 meter per second square. With this, let me stop here. See you in the next class. Thank you.